So hello ladies and gentlemen, and now we're starting our math practice session. The questions today we will cover actually are already on the channel. We will go all over them and some of the new ones. So let's start with this one. So here we are required to calculate the value of it. Actually, if we do the way we're supposed to do, it will be very long. If we do it so it would be like 1 over 3 plus 1 over 15, etc. And it's very hard to calculate these numbers in this way, because we have to find a way to make it easier for us. So let's see what we can do with this. 1 over 1 multiplied by 3. Let's assume that we need to do something with 1 over 1 and with 1 over 3. We can a common denominator would be 3, so it's 3 minus 1. It would be 2 over 1 over 3 multiplied by 3. But this is twice much as this one. So if we multiply it by 1 over 2, we can get this would be equal to this. So it works for this one only. Let's check it with the other ones. 1 is 1 over 3 minus 1 over denominator would be 3 multiplied by 5. Here it would be 5 minus 3. Again, we get 2 over 3 multiplied by 5. Again, if we multiply this by 1 over 2, this one would be equal to this one. And let's check if this works for all of them. 1, 5 multiplied 7, it would be 1, 5 minus 1 over 7, and this would be 7, and it would be 2, 5 multiplied by 7, or this, but this one. Actually, we check all of them, they would work, but let's do it. 7 multiplied 9, it would be 1 over 7 minus 1 over 9, and this would be equal to 7 multiplied 9 in the denominator and 9 minus 7 denominator, and it would be 2 over 7 and 9. So yes, and if we multiply this 1 over 2, we again get this one. We need, let's check this one, it's the last one. 9 multiplied 11, 1 over 9 minus 1 over 11, it would be 9 over 11 and 11 in denominator, and 11 minus 9, it would be 2, 9 and 11. So this again, we get this one. So we found it, but did we find the value of this? No. So now, yes, delete. Now let's write all of them as 1 over 3. This we get what? 2, 1, 3. So if we multiply this to 1 over 2, we get this. So we will write this one equals to 1 over 1 minus 1 over 3 multiplied 1 over 2. This would be again 1 over 3 minus 1 over 5 multiplied 1 over 2 plus, we write this one, 1 over 5 minus 1 over 7 multiplied 1 over 2 plus, and this one, 1 over 7 multiplied 1 over minus 1 over 9 multiply 1 over 2. 1 over 9 minus 1 over 11 multiply 1 over 2. This all equals to this, right? So these values are the same. Now we need to calculate this one. So we have the common 1 over 2. Let's write it. 1 over 2 multiplied what here? Plus 1 over 3 minus 1 over 5. 1 over 7 plus 1 over 7 minus 1 over 9. And now we need to calculate this. So we see that minus 3 plus minus 1 over 3 plus 1 over 3 is 0. Minus 1 over 5 plus 1 over 5, 0. 1 minus 1 over 7 minus plus 1 over 7 is 0. And 1 over 9 plus minus 1 over 9 is again 0. And we're left with 1 over 2 multiplied 1 over 1 is 1 minus 1 over 11. This would give us 1 over 2 multiplied to 10 over 11. And this would be, let's write it here, 5 over 11. So this is the answer for this question. If you have any question regarding this question, please comment it so I can look and give insights on this. If not, let's follow to the next question. So here, what we need to do here, we need to find x. How are we going to find x? It's exponential equation, and usually we do it with logarithmics, but now it's too long to do with logarithms. We need to find out a way to solve it without logarithmics. I guess there is a typo. I look at the question, there should be 2. 2 over 2x equals to 3, x over 2, 1. What we would do here, we would write this one as 4, like 2 to the power of 2 in the power of x equals to 4 to the power of x. And we will write that 4 to the power of x equals to 3 to the power of x over 2 plus 1. And later we will solve it in a different way. We will write that x over 2 would be a, and then x would be 2a. So let's do this here. Actually the question is 2, so here we don't need this part. Just substitute this way. We get 2 to the power of 2a equals 3a to the power of 3 to the power of a plus 1, and it would be 4a equals to 3a plus 1. And what we do now we will do logarithmics. So if we know that 2 to the power of 3 equals 8, and logarithm of 2 to 8 equals to 3, here we would get that log of 4, here is 2, here is 4, and here 8, so it's 3 to the power of a plus 1 equals to this to the power a. And now we have written that this is the a. So let's put 4 of 3 to the power of all of this, logarithm 4, 3a plus 1 and plus 1 equals to a, log 4, 3a plus 1. And since logarithms are the same, we will write it, we just get rid of them, and we will write that 3a plus 1 equals to 3a to the power of a plus 1. And here what we do, we would write the 3, let's choose another color, the 3 to the power of a plus 1 can be written as b. And here we get that 3 to the power of log 4 of b plus 1 equals to b. Let's do minus 1 from both sides. We would get 3 log 4 to b equals to b minus 1. And we again do logarithmics here to see what we get. So logarithmics of what? Of b. But before doing that, we can change 3 and b, right? Because there is a rule that allows us to do that. So b to the power of log 4 of 3 equals b minus 1. And now we do logarithmics here. So logarithm of b and b minus 1 equals to logarithm 4 and 3. And look, this is b, this is 4, b minus 1, and this is 3. So if b equals to 4 and b minus 1 equals to 3, then b equals to 4. So we found b, but this is not the answer, we need x. So b, where we use b, what? Here is b. So 3a to the power of 1 equals b, and this equals to 4. So 3a plus 1 equals 4, then 3a equals to 3, and a equals to 1. Again, we found a, but we need x. Where did we use a? So we just wrote that x over 2 equals to a. Do you remember that when we used here? So x over 2 equals a is 1, x equals to 2. Let's check it. 2 to the power of 2 equals to 3 to the power of 2 over 2 plus 1. This is equal plus 1. So it's 4, and this is 3 to the power of 1 plus 1. It's 4 equals 4. Yes, we found x. Let's go to the next question. Here is the system of equations. We need to solve it. It's a special pi day system of equation. We have 3 and 14 and 3 and 14 here. So actually we what usually would do, we would try to get rid of one of x or y, but then we would need to multiply both sides to such a weird number like 14 and 3 or something else. But I just see that these numbers are similar, so it's 3 and 14, and it's also 3 and 14. I just sum them. I just do plus, and I get what? 17y plus 17x equals 205 plus 85. It makes 209. No, 290. And if I divide both sides to 17, what I get? So I divide by 17. I would get y plus x equals to, what would that would be? That's a very strange number. I guess I made a mistake somewhere. Yes, this should be 84. Sorry, guys. So if it's 89, and when we divide 289 by 14, why 14 by 17? We get 17. Actually, it's 17 squared, so shame on me. So it's much easier to use this one and any of this. So if it's 1, so let's multiply this by 3. We get 3y plus 3. And let's use again this one. So let's see what we get. 3y plus 14x equals to 84 minus 3y plus 3x equals to 51. Y minus 3y is 0. 14x minus 3x, it makes plus 11x. And this one would equal 84 minus 51 is 33. So x equals to 3. So we found it. And let's put it here. So y plus y plus 3 equals to 17, y equals to 17 minus 3, and this equals to 14. Yeah, so the answer would be 3 and 14. Again, we get the pi number. Let's go to the next cubic roots. It looks like we can't get any cubic root from out of any of them, so what we're gonna do? But when we see such questions, we just need to do what we can do, and then everything will be easier. Just let as I can write it 8 multiplied 8. 54, it's 6 over 9 plus 3. 128, it's 64 multiplied 2. Let's continue. Let's continue here. It's 3. It's 2 to the power of 3 multiplied 2 to the power of 3 plus 3. It's 2 multiplied 3 multiplied 3 to the power of 2 plus cubic root 64. As we say, it's this, so it's 2 to the power of 3, and this would equal to 3, so it's 6 plus 3. We get here, what we get here, it's 2 multiplied 3 to the power of 3, because it's 1 and 1 plus 2 is 3, plus cubic root of 2 to the power of 6 multiplied by 2. Let's follow what we get there. And so we get here 2 to the power of 6 over 3 plus 3 over 3 square cubic root of 2. So this 3 divided by this 3. So here it's this 6 divided by this. Oh, sorry, I said this 3 divided by this 3. 6, 3, 2, 6 over 3, and still cubic root of 2. We get here, it's 2 to the power of 2 plus here we get 3 to the power of 1, and still we have cubic root of 2 and cubic root of 2. And this would give us 4 plus 3 cubic root of 2 and plus 4 and cubic root of 2, and this would give us 4 plus 7, so 3 and 4 give us 7 cubic root of 2. So this is the answer for this question. Let's follow. So we need to find the value of it or evaluate. When we have expressions are, so if mod x equals to x or minus x. And when, if x is more or equal to 0, and minus x when x is a negative number or non-positive. So we just need to know what is this. It's if it's positive or negative, and then we can write the result this module signs. So how we compare square root of 6 and 3? To compare it, we need to know if when we do minus, if it's more than 0 or equals to 0 or less than 0. And when we do that, we just need to write this in such a form that would be similar to this. So it's square root of 6 minus square root of 9. Numbers within the squares are 6 and 9. So 9 is more than 6. Then, since 9 is more than 6, then square root of 9 will be more than less than 3. Then it means this will be, when we evaluate this, we write minus and the expression inside, square root of 6 minus 3. So plus, let's evaluate this, square root of 6 minus 2. Since 6 is more than 4, then square root of 6 is more than 4 is more than 0. So this is more than 0. We keep it as it is, and we write square root of 6 minus 2. And this would be equal to minus square root of 6 plus 3 plus square root of 6 minus 2. This would be minus square root of 6 and 6 are gone, and we have 3 minus 2, it equals to 1. So now here we need to evaluate this expression. Yet let's not panic, just focus on what we can do again. And there are two ways actually. We know that a to the power of 2 minus b to the multiplied a plus b. So we can use this now and try to get rid of the power of 2 and then solve it. Let's do first getting rid of 2. So when we have a to the power of b and to the power of c, we can write a to the power of b multiplied c. So we multiply them, get 7 to the power of 6008 minus 7 to the power of 6004 divided 7 606 minus 7 602. And what we get here, we can write 6004 multiplied 7 to the power of 4, because a to the power of x multiplied a to the power of y equals ax plus y. This is here, 6004 and 8. And why we did 6000 and 1004, so they would be equal. And we can do 2 instead of 4, because we in denominator we have 2. It is the least one, and here it's this one is least one. So 7 to the power of 6002 multiplied 7 to the power of 4 minus 7 to the power of 6002. So we have 7 to the power of 6004 in nominator, so we can write it like this, 6004 multiplied what we left here, 7 to the power of 4 minus, and here it's 1, and let's do it here, 7 to the power of 6002, what we left here, 7 to the power of 4 minus 1, and here we get rid of this, and we have 7 to 6004 over 7 to the power of 6002. Here we know that a to the power of x divided by a to the power of b equals ax minus b. We do this here. 7 to the power of 6004 minus 6002. It gets 7 to the power of 2 and it's equal to 49. So this is the one way to solve it. Let's do the other way with this one. Okay. So what we know that a squared minus b squared equals a plus b multiplied a minus b. Let's do it here as well. To the power 3002. Here 7 3004 minus 3002 divided plus 7 to the power of 3001 multiplied 7 3003 minus 7 3001. So the least value out of brackets, and it would be 7 3002. Here we get 7 to the power of 2 plus 1. Here we got this one, and here it's the same again, multiply 7 3002. We get 7 to the power of 1 minus 7 to the power of 2 minus 1. Here we get 7 to the power of 3001. What we left here again, square plus 1 plus 7 3001, 7 square minus 1. So we get rid of this ones and this ones. What we left here, 7 to the power of 3002 plus 3002 minus 3001 minus 3001. Here we get 1 and here we get 1, so it's 7, 1 plus 1, 7 to the power of 2, and it equals 49. So pretty long solution. I prefer the previous one. So in these questions we are required to find the area of the shape. Oh, sorry guys. How to define the area? And we have the functions here. It's x plus 1, and this one is parabola 2x squared plus x minus 1. To find the area between functions, we do integrals, right? And 2 from a to b. And the area, they ask us just this area. And how we would find it? We first need to find out the limits of the area, boundaries, let's say. We know that this is y axis, so y, so it's 0, so we will have 0 here, but now we will need to find this point. And how do we find it? If it's an intersection of two functions, we can write that this function x squared plus x minus 1 equals to x plus 1. To get rid of x, so we get 2x squared minus 1 minus 1 equals to 0. We get 2x squared minus 2 equals to 0. So 2x squared minus 1 equals to 0. X squared minus 1 equals to 0. X squared equals to 1. So x equals plus minus 1. So see, we found functions intercepting 2 points. One is this and the other one is this. And this is on the left side of y, and it's minus 1, and the other one is 1. Actually, they're giving us this, but this is not properly. We need to check it. Maybe it's just coincidence that this is the same. So now, since we found out the boundaries, let's clear this. So this point is 1, this x, this point is y. We don't need this. So we will have this with 1, 0 here, and x, 2x squared plus x minus 1 minus x plus 1, but we need to write it this way. So it doesn't really matter. We can do this in different way, as since this function can be considered as higher, we can write as 0, 1, x plus 1 minus 2x squared plus x minus 1. This 1 x minus 2x squared minus x 0, 1 x and 2 minus 2x squared. So now we need to write it as the way it should be. So it would be 2x minus 2x cubed divided by 3. Now we know the boundaries 0 and 1. We first put 1 here, and then we minus with the 0 multiplied 1 to the power of 3 divided by 3 minus 2 multiplied 0 minus 2 multiplied 0 to the power of 3 divided by 3. We get here 2 minus 0, so it's 0, and we get the answer like 6 minus 2 over 3. This would be 4 over 3, or 1 over 3. So let's go to the next question. It's the finding percentage of a number. So how we would do, we will write that this is our 100 percentage, and we need to find 25%. So we write 1, and I don't know what number, so x is our 25%. And we cross multiply, x multiplied 100 equals 25 multiplied 180. So x equals 25 multiplied 180 divided by 100. So when we do this, it is 4, and 180 divided by 4 is equals to 94. So 90 divided by 2, and this equals to 45. 5% of 108. Go to the next question. So we, in a circle, we need to find the degree of this angle, and this is the center. So let's see, we have an angle that's where there is the arc, and there's the angle on at the as small as this one. So if it's x, it means that x divided by 2 equals to 70. And we find out that, let's not call it x because it's x we have here, so it's a. So a would equal to 70 multiplied by 2, and this is 140. This angle, on which vertex is located of the arc. So x equals to a, and this equals 140. That's it. So thank you guys. Let's check if you have any questions. If you do, please comment them, and let's try to solve. If not, we will finish. And there are links for your questions to be submitted, and for SAT practice we are planning to do